Okay, then thank you. Let's start with the session, guys. See, coming to today's session. Okay, coming to today's session, we will start how to write our DAO class using Java Persistence API. The first example, whatever that we discussed so far in Hibernate, the first example, we have created our application. We have created our application using pure Hibernate application. Means we have not used any JPA related concepts in that. That is a pure Hibernate application. So the drawback of creating directly pure Hibernate application is, if at all you want to change in your DAO class, if you want to change from the current ORM tool, that is Hibernate, and to another ORM tool, for example, so then you need to remodify the entire DAO classes. So which makes your DAO classes are tightly coupled with the Hibernate framework. Your DAO classes are tightly coupled with the Hibernate tool or Hibernate framework. That is a drawback. This is called a tight coupling. But now I want to make my DAO classes as loosely coupled with the ORM tool. I want to make my DAO classes as loosely coupled with the ORM tool, which means if at all I want, I can move from my current ORM tool to the another ORM tool also, without making many changes to my code. With only few changes, with only little bit of changes, my same DAO classes will also use another ORM tool to work with the database. So that is what I want to make my DAO classes as what? Loosely coupled with the ORM tool like Hibernate. So this is where we have to use JPA. As we know already, JPA is a specification. You know that JPA is a specification. It is a specification, and a JPA specification has a different or multiple implementations. We call all of them as JPA providers. Each implementation of JPA is called JPA provider. Each implementation of JPA specification is called JPA provider. Hibernate is also one of the JPA providers. There are many JPA providers are available, and one of the most popular JPA provider is Hibernate. Okay, so today we want to write our DAO classes. We want to learn how to write our DAO classes using JPA specification. And we want to run our application by configuring Hibernate as a JPA provider. Okay. If at all I want to change from current JPA provider to another JPA provider, what I need to do? I just need to only modify the configurations, but not the code. just by doing little bit changes to the configurations, my entire application is now moved from Hibernate as a JPA provider to the next new JPA provider, whatever you are choosing. For example, I want to change from the Eclipse Hibernate to the Eclipse Link. Eclipse Link is also one of the JPA provider. Like Hibernate, it will also perform database operations on objects. Okay, like that, not only Eclipse Link, there are many JPA providers are available. Later, you can go through the list of JPA providers. Okay, you can find them. But the most popular one is Hibernate. Okay. Coming to today's point. First, we want to know how can I write mappings, or how can I define the mappings between my Java class, and otherwise I can call my Pojo class, and the database table. Here now, from today onwards, you are not finding Hibernate mapping file and Hibernate configuration file. When to write Hibernate mapping file and Hibernate configuration file? So if you are working with pure Hibernate application, you are not using any JPA specification, then you need to write the Hibernate mapping file and Hibernate configuration file also. Like hbm.xml, cfg.xml. Those files you have to write at that moment. But today we are not writing the application with a pure Hibernate application. We want to use JPA specification to write our DAO classes. Okay. Then what I need to do? I have to use JPA annotations. I have to use what now? JPA annotations to define the mappings between my Java class, that is called Pojo class, and the database table. Let us see what are the annotations now. That is what first we are going to understand now. We are discussing about what are the annotations we use to define the mappings between what and what? Our Java class and the database table. Okay. Observe here. Let us try to understand about what are the annotations. Okay, let's start one by one. First annotation. So these are annotations I'm talking about. JPA annotations for mapping. First, we'll understand about JPA annotations for mapping. I would like to tell one more thing. Okay. JPA, the entire JPA specification is provided in a single package. That package name is javax.persistence. That is a package name of JPA. I repeat once again, the JPA specification is provided in a single package. That single package name is javax.persistence. That is a package name of JPA. Okay, do remember that. What's the package name? javax.persistence is the package name of JPA. This package name will help you in the next upcoming classes. So that is the reason why I'm talking about this point today. Okay, right? What is the package name of JPA specification? javax.persistence. Let us move on. Let us go ahead. JPA annotations for mapping we are discussing. The first annotation that we write, @entity. What's the annotation name? @entity is our annotation. Okay. Let us identify what is @entity. Actually, when you're writing annotations, here little bit annotations knowledge is required. I'm just giving only small information. In spring class, you will get more knowledge on annotations. But first understand, annotation is also like an interface. Annotations are like interfaces. But we call annotations as special interfaces. Because if you want to create a normal interface, we use a keyword called what? Interface. If you want to create a normal interface in Java, what is the keyword we are using? Interface keyword we are using. But if you want to create an annotation, we have to use a keyword called @interface. So that is a special keyword given for creating interface. So every annotation is also an interface. It is not a class, it is an interface. First point. Like if you have interface in Java, you are writing implementation class, right? Whenever you are creating an interface, for that interface, what are you creating in your program? Implementation class you are writing. If it is an annotation, for that annotation also, parser class is created. What is created? Parser. When you are working with Hibernate and Spring, you are using the annotations which are already provided by your framework. What are you using? Your annotations are already provided by your framework only. You are not creating them. You are just using them. Which means what? Already the parser classes are also provided by your framework only. Suppose tomorrow I wish to create my own annotation. Yes, possible. I can also create my own annotation @shaker. I can create myself. Then who is responsible to write that parser class also? By me only. By me only. What about @entity? It is not my own annotation. It is given by framework. It's given by JPA. JPA provided this annotation, right? It's implementation. Implementation means here we call it as parser. Normal interfaces contains implementation classes. Annotation interfaces contains parser classes. Those parser classes are given by the JPA providers. Who is our JPA provider? Hibernate. So basically understand here, annotations are given by JPA specification. Annotation parsers are given by Hibernate. Hibernate, Eclipse Link, OpenJPA, blah, blah, blah. These are all called as what providers? JPA providers. JPA providers. That should be very clear. Do remember this point. Every annotation is what? An interface. A special interface. It is not a class. If it is a normal interface, what's the keyword we use? Interface keyword we use. If it is an annotation interface, what is the keyword we use? @interface is a keyword I have to use. Okay, right. Normal interfaces contains what? Implementation classes. Annotation interfaces contains what? Parser classes. That is the difference. And while creating annotations only, at the time of creating an annotation, where it should apply, where I have to use this annotation in my program, in my code, in a program for which element it is applicable. Element in the sense, it can be class or interface, or it can be field, it can be method, it can be constructor, it can be parameter. Where it should be applied, that is also defined at the time of creating that annotation only. For example, you take entity. Today we are discussing first annotation, what? @entity. @entity is called class level annotation. Like that, we have annotations to be applicable at different levels. Class level annotations, method level annotations, field level annotations, constructor level annotations, parameter level annotations. Like that, different annotations can be applied at different levels. This is what level annotation? Class level annotation. Means what? Where can I apply this? Where I can use this annotation in my code? At class level. At class level means before the class. At method level means before the method. At a variable level means before the variable. At constructor level means before the constructor. At before parameter. Like that. Like that. Getting my point? Like that. So what's the annotation I'm talking about? @ entity. It is what level annotation? Class level. Where I can apply it? Before the class, I have to use it. And by writing this annotation, it will declare that my Java class is an entity class. My Java class is an entity class. In JPA terms, our POJO classes are called entity classes. Entity class is nothing but POJO class, which is mapped with a table. Normal POJO class is not entity class. We call a POJO class which is mapped with a table is called entity class. So how can I declare? How can I declare that my class is an entity class? By using annotation called @entity. Where should I use this? At the class level. At the class level, I have to use this annotation. Okay. Next, basically, what this annotation will do? It will declare that a Java class is or a POJO class as an entity class. It will declare that a POJO class is an entity class. A POJO class is an entity class. Okay. Then we have next annotation. @table. So what's the next annotation I'm writing? @table. @table. I will explain you once again. Yes. Observe clearly and try to understand point clearly. Okay. What is the annotation name, guys? @table. @table. Okay. @table. Guys, observe it. We know that entity class is mapped with a database table. Na? That a table name, you need to specify the table name by using annotation called @table. So @table is to map your Java class with a table. Normally in mapping file, you written class tag. Class tag contains name attribute, then table attribute. We have written previously hbm.xml file, but now we are not writing hbm.xml file. What are you writing? Annotations we are writing. So @table annotation is to specify the table name. If, for example, your class name and your table name in database are matching together, then no need to write this table annotation. It is optional. Entity is compulsory. Without writing @entity, your class is not going to become like an entity class. To declare that your class is an entity class, what's the annotation? @entity. Next one is what? @table. Sure. @table is to map your Java class with a database table. To map your Java class with a table in database, what's the annotation? @table. If your table name in database also same as your class name, then optional. Which annotation optional? Table. Where do you write this annotation? Where do you write this annotation in your program? At the class level. At what level? Class level. Entity annotation also, where do you write it? At the class level. Okay. So observe here. What I'm writing? It is used to map a Java class or POJO class with a table in the database. In the database. It is used to what? Map a POJO class with a table in the database. What is the annotation for that? @table. @table. Okay. Observe. Next one. First 4 annotations we'll discuss. Initial annotations. Later on, more annotations will come. The next one. @ID. @ID. First 2 are class level annotations now. So what and what are the class level annotations here? entity and table. Both are class level annotations. id is a field level annotation or method level annotation. Means we can write this annotation at field level or at method level. Field level means variable level. Field means variable or attribute of a class. That is called field level. Mostly we write these annotations at the field level only. But actually we can write this annotation at field level or at the method level also. At a field level or at the method level. Okay. So what is the purpose of this id? This annotation can be used to declare or map. Okay, is to map a variable. Variable means field, na? To map a variable with a primary key column of the table. Primary key column is called id column. Unique, na? That's called what column? id column. So which annotation we have to use in our Java class to map it with a primary key column? @id. So it is used to map a variable in our Java class. In our Java class with primary key column. With a primary key column in a table. With the primary key column in a table. Then next one is column. Do remember, every annotation name starts with capital letter. I'm writing id, I capital, column, C capital. Okay. So what you understood? Every annotation name will start with a capital letter. Column. Annotation is column. So it is used to what? It is used to map a variable with a column in the table. With a column in the table. These are the basic annotations. These are the basic annotations used for mapping. Okay, I will explain you now. I'll explain you how to do this. Okay, let's go ahead. See here, I'm writing an example. So for an example, I'm writing a Java class like this. For an example, I'm writing a Java class like this. For example, I have a class called, I will write annotations, but first I want to write class like this now. Public class employee. Public class employee. Suppose I have variables like this. Of course, I am not writing annotations. I'll write the annotations now. You don't write along with me because I'm going to make some changes. Integer employee number. Private string employee name. Private double salary. Private integer department number, DEPT number. Then I have defined setter and getters. I have a class like this. Now this is my Java class. Employee is my class. My requirement is what? What is my requirement in my application? This employee class object. What an object of employee class will store? What an object of employee class can contain? Employee number, name of the employee, salary, and department number. Now, what is my requirement? I want to store this employee object in the table, database table. My database table name is what? EMP. Okay, I want to save an object of employee class to the database table. The table name is EMP. whenever you want to, if you want to store an object of this employee class with a database table, you have to declare that this class is an entity class. I have to declare this class is an entity class. That's for sure. So how can I declare that my class is an entity class? For that, I have to use annotation called @entity. Annotation I'm writing is what? @entity. Yes, we'll start @entity. Look at this, @entity. What's the annotation I'm writing? @entity. Okay, at what level we are writing this? Class level, before the class. And to which table I want to map it? @table name equal to emp. Name equal to emp. Table name emp. That's done. Next, coming to employee number is a variable. I want to map it with which column in table? EMPNO is one column is there in my EMP table. EMPNO is a primary key column now. So to map it with that column, first of all, which annotation I have to use? @column. Column name equal to, what's the column name? EMPNO. That is column name. Now again coming to the point. EMPNO column is what key? Primary key. So @ID. @ID. Okay, @ID. Got it right? Excellent. Let's move ahead. Once again, here, employee name. Observe here. If, for example, if column name is the same as your variable name, then no need to use column annotation to map it with the column. No need to specify the column name with the column annotation. When, if the column name is also same as your variable name, I am writing @column name equal to ename. Okay, @column name equal to what now? Ename. What is ename? Is the name of the column, database table column name. What's the column name? Ename. Ename. Nice. Next, @column. @column name equal to sal. Okay, you know that table name, column names we can write in any case, lowercase or uppercase. Just to easily identify, I am writing in uppercase, but don't feel that I must write in uppercase only. You can write even in the lowercase also. Next one is what? @column. @column name equal to DEPTNO is my column in the table. @column is to specify database column name, but when it is optional, if column name is the same as my variable name. For example, my variable name is also sal only, or the column name also. @column is to specify the database column name, na? Right. What is my variable name? Sal. Column name is also sal. Nothing but what column name is same as my variable name, right? What can I do now? I can remove this. I can remove this annotation, no problem. I can avoid it. I can remove this, but I cannot remove here. I cannot remove here. Why? Column name is not matching with my variable name. So I must write this annotation called @column. That's the difference. Okay. Okay. Right. What is my class name here? Employee. Suppose my class name is EMP. Okay. Now tell me, my class name is EMP. At the rate table is specify the database table name. Na? What's the table name? EMP. What is my class name also? EMP. So both are matching together. So what can I do now? Yes, it is optional to write this annotation called what? At the rate table. Getting my point? Okay. Okay then. So basically what happened here, I'll write. What happened here? I have a table called EMP. So here is my table. My table name is EMP. I have a table like EMP. And my EMP table has columns. Employee number, name, sal, DEPT, and O. These are the columns of my table. And I'm mapping them. Okay, my table name is EMP. And my columns names are EMPNO, ename, sal, DEPT, and O. These are the columns I have with me. These are the columns. These are the columns I have. And this is the mapping I did. So I did the mapping. Okay, I did the mapping. Employee class is mapped with the employee class is mapped with the EMP table. Employee number is mapped with the EMPNO. Employee name is mapped with the ename. Salary property is mapped with the column sal. DEPT number is mapped with the DEPT-NO. Understood now? Right. This is how do we do the mapping. So what are the annotations I've used? At the rate entity, at the rate table, at the rate ID, and at the rate column. At the rate column. Got it, right? Right. These are the four. What annotations I'm using at the class level? Entity and table. What annotations I can use at variable level, means field level? ID and column. So when table annotation is optional, if the class name is matching with the table name, then table is annotation. If the variable name is matching with the column name, at the rate column annotation is also optional. You got my point? Right. Guys, are you getting it online? Type C or N in chat box. Okay. Next. Let's move ahead. Okay. These are basic annotations. Many annotations you have to discuss, but basic annotations required for mapping will be like this. These are the basic annotations required to do the mapping. Sure. We will go ahead. We will go ahead. We'll discuss next. Okay. Okay. Let's have one more thing. Okay. Let's have one more thing. Let's have one more thing. Observe here. So now, during this mapping, when I'm doing this mapping, okay. For example, sometimes what happens, our class contains more attributes, but in the table we have less columns. So these are very important things. Seems to be very minute, but in every interview we ask this type of questions only. In every interview we ask that type of questions only. Okay, right. What is the point here? I have a class. In class, I have more number of variables. But in my table, I have less number of columns. For example, if you look at this now, We have matching number of attributes and matching number of variables. The columns. What is there? Employee table is there. The employee table is mapping with EMP. How many attributes I have? 4. How many columns are there in table? 4. Yeah. Means here we have a doubt. Doubt number 1. At the time when we are writing our entity class, now from now onwards we call our Pojo class as entity class. While writing the entity class, do we have any requirement that the number of variables and the number of columns, number of variables and number of columns, whether both should match or not? That is the question. If you look at this example, we have how many variables in the employee class? 4 variables are there. And how many columns are there in the table EMP? 4 columns are there. There are 4 variables here. There are 4 columns there. Numbers are matching. Numbers are matching. But suppose my class has 5 variables. Table has 4 columns. Numbers are not matching. Numbers are not matching. Because how many variables I have? 5. 5 variables I have. But how many columns are there in the table? 4 only. So then how can you do mapping? This type of questions you will get an interview. Reverse now. My class has 4 variables. But in the table there are 5 columns. In the table you have 5 columns. Number of columns are 5. But how many variables you have in your class? 4 variables only. Can we do the mapping? Can you map this Java class with the table? This type of question you will get. Okay, right? Let's find a solution for that. I'll explain one by one. Listen here. Let's understand now. Okay, I'll explain. Observe here. Assume that, for example, one more example I'm writing here. Example. Okay, example. I'm writing entity table name equal to TBL underscore student. Assume that my class name is student class. Okay, what is my class name? Student. I have a class called student class. What's the database table name? TBL underscore student. That is the table name. What I am writing here? Class. What's the class name? Student. What is my requirement? I want to write variables like this. Private, later annotations. Private, integer, student ID. Private, string, student name. Private, integer, marks. Private, observe here, private, string, result. I have 4 variables now. Remaining all setters, getters, setter and getters. And very important point to understand here is, whenever you are creating any entity class and you are mapping with a table, do remember that that class must contain a parameterless constructor. What constructor? Parameterless constructor. Each variable must contain setter and getter methods. Each variable must contain setter and getter methods. One more thing is, if you are using remote database, what database? Remote. Currently, when you are practicing, you are working with local database. If you are working with remote database, you have to write your class implements serializable. You have to write your class by implementing serializable interface. Because what kind of objects can be transferred in a network? Only serialized objects are transferable in network. Where is your database? Remote means not in your machine, it is there somewhere else. Then how can you send this object to the database? If it is a serializable object only, it can be transferred in the network. Otherwise, it cannot be. So how can I make my object a serialized object? By implementing the class from serializable interface. By implementing the class from serializable interface. Getting my point, right? So better from now only, whenever you are practicing, better to write all your entity classes implements serializable. Do you know serializable is a what type of interface? Serializable is what type of interface? Write in chat box. Serializable is what type of interface? Write in chat box. Serializable is what type of interface? Write in chat box. Serializable is a marker interface. Marker interface in the sense what? It does not contain any abstract method. Okay. How many types of interfaces are there in Java? Write in chat box. Okay. Okay. Nice. Answer is 3 types. Normal interfaces, marker interfaces, and functional interfaces. Okay. Normal interfaces, marker interfaces, and functional interfaces are the 3 types of interfaces we have in Java programming. Okay. Okay, guys. Nice. I will go ahead. Observe here now. Remember, everyone, whenever you are creating an entity class, okay, 2 rules are important here. Rule number 1, the class must contain parameterless constructor. What type of constructor? Parameterless constructor. It is compulsory. Second, each variable, each variable must have respective setter and getter methods. 2 points are very clear. So generally, we are not writing any constructor, for example. If you are not writing any constructor, Java compiler will add a default constructor. Na? The default constructor is a parameterless constructor only. Na? So we don't need to worry about that. And at the time when you are writing the class, you must define setter and getter methods. Define setter and getter methods by yourself. Are you getting my point? Very good. Next. Later, not only first example, after the second example or third example, we will use one API in Java, a third-party API in Java called Lombok API. What API? Lombok, L-O-M-B-O-K. Lombok API we use. If I use a Lombok API, I can avoid writing the boilerplate code. I can avoid writing the boilerplate code. Boilerplate code meaning repeated code. For example, if you take JDBC programming, you have repeated code, na? Load the driver, connection, statement, result set, close. You have repeated code, na? That type of code in Java is called what code? Boilerplate code. Boilerplate code. To avoid writing the boilerplate code, we have an API, a third-party API in Java that is called Lombok API. What API? Lombok API. So we'll discuss later on what happens after first or second example is completed. We will never write setter getter methods manually, or we don't generate them using our IDE. No need of writing setter getter methods in a class. If I write annotation called @setter, @getter, automatically setters getters generated at the runtime. That is called Lombok API. Okay, @no args constructor, @all args constructor, like that annotations are there. Okay, if I read that annotation, automatically constructors are generated. This is all called as a Lombok API. Okay, that will come next. Currently, I want to continue here. My class name is what? Your student class is there. These are the variables. First, I would like to map it with the table. Let me show you the table first. I have a table here. Here my table name is student, TBL underscore student. And it has columns SID, S name and marks. So my table is TBL underscore student. This is my table. And my columns are SID column, S name column, marks column. Observe here. Here you need to understand now. If you look at this, in my class, how many variables I have? 4. Student ID, student name, marks and result. But here in the table, 3. Okay, let me first write. First, let us add the annotations. Let me add the annotations. 1 minute. Let me write the annotations now. Tell me what the annotations I'm writing. @ID. @ID. What's the next annotation? @column. @column. Tell me @column. What's the column name? Column name. What's the column name? SID. Column name is what here? SID. Here @column name. What's the name equal to? S name. Yes name. Or the next one? Marks. Marks. Or the annotation, actual annotation? No, we can write annotation, but optional. Column name equal to marks. But it is optional. Okay, first I want to add now. Or the next one? Result. But observe it. I have a variable called result here. But in the table, you don't have any column called result. Okay. If I leave like this, then what Hibernate assumes? There is a column in the table with the name result. That's the reason why I am not writing @column annotation. Because if you don't write @column annotation, then what Hibernate feels? Column name is also result. That's what the meaning now. But actually I don't have any column called result, right? Do you have any column called result in the table? No, we don't have the column. We have only 3 columns. I don't have 4th column. Get my point now? That is where you have to learn. What you have to learn now? You have to learn that there is one annotation given called @transient. Okay. If you don't want to map a variable with any column in the table, then you have to declare it as a transient variable. How can you declare that it's a transient variable? By using the annotation called @transient. Is it clear now? So one more annotation also you learned today. What is that? @transient. Observe here. How many variables are there in my entity class? 4. In the table, how many columns are there? 3 columns are there. Okay. If you have more variables in your class, if you have more variables in your class and less columns in the table, can you map the Java class with the table? Can you do the mappings? Yes, we can do it. Right? If a variable has no column in the table, if a variable does not have any corresponding column in the table, you have to declare that variable as a transient variable. How to declare it's a transient variable? By using annotation called @transient. Okay, nice. Good. I can write, I just want to write box like this. Then I want to explain. See what I did here. I did mappings. I did the mapping. This student class is mapped with the TBL student. This student ID is mapped with the SID. The student name is mapped with the S name. And what? This marks is mapped with the marks. Okay, we have only mappings like this. But we don't have any column called what? Result. So we are declaring it as what? A transient. So I would like to give a question and answer format. What is the question? Can we map a Java class? Okay, can we map a Java class with a table if it has more variables? What is the answer? Yes. Answer is yes. Okay, so which annotation will help you to do that? @transient. Can we map a Java class with a table if it has more variables? Yes. Yes. What's the continuous answer I want to give? Use. What's the annotation name? @transient for a variable which does not have a column in the or have a corresponding column in the table. Corresponding column in the table. Right? Yes. Use @transient for a variable which does not have a corresponding column in the table. Now this is called the transient annotation, what we have to use. Next. Let us talk about the one more example. Let's talk about one more example. Okay. Now my next example is, this time I'm taking reverse. Reverse means what? Database table has more columns, but my class has less variables. For example, I'm writing something like this. @entity. Table name equal to EMP. Public class employee. Okay, same. I'm writing same. @ID. @column. Okay, column name is EMPNO. Or I'm writing simply private integer EMPNO. Private string ename. Private double sal. Private integer DEPTNO. Okay, setters and getters. This is my class. Now my table name is EMP. Here I have a table called EMP, and this EMP table has columns. It has columns. I'm writing the columns names here, and I have EMPNO, ename, sal, DEPTNO, and even I have some other called manager. Observe here. Table name is EMP. Columns are EMPNO, ename, sal, DEPTNO, and manager. MGR. Okay, I have a column called MGR, which is manager. Example. Now what I'm asking you, this time how many variables I have? Variables are 4, but how many columns are there in the table? 5. Observe clearly. Now this time I am mapping like this. Now this example says that here is my, see why I'm not writing annotation like @column, @column, all I am missing out. Because what is my variable name here? What's my variable name here? EMPNO. My variable name is EMPNO. What is the column name there? EMPNO. Both are matching now. What is my variable name here? E name. What is the column name also? E name. Both are matching, right? That's the reason why I'm not writing which annotation? @column. Observe here. This is my employee class, which is mapped with a table called what, guys? EMP. This EMPNO is mapped with the EMPNO. This E name is mapped with E name. This SAL is mapped with the SAL. And the DEPTNO is mapped with the DEPTNO. Blah, blah, blah. Correct. But what is additional variable? MGR. Question is what now? Can we map like this or not? Can we map like this or not? Is a question. Getting my point? Right. Answer is yes. Answer is what here? Yes. Provided if that column does not contain not null constraint. If that column does not contain the not null constraint. If that column has a not null constraint, then we cannot map. Why? Because that column does not allow null value. Not null constraint you learned in Oracle, na? Unique constraint, not null constraint. What other constraints you know? Check constraint, default constraint, and primary key constraint, and foreign key constraint. There are 6 constraints on the database, right? What are the 6 constraints on database tables? Unique, not null, check, primary key, foreign key, and default. These are the different database constraints. Okay. Right. Observe. Here answer is yes, we can do this. But provided if this MGR column is not a not null column. If this MGR column has a not null constraint, it does not allow the null value now. Then I cannot save the employee object in the table. If there is no not null constraint, yes, I can map it. What happens when I'm saving an employee? Employee number, name, salary, department number are inserted. MGR becomes null. MGR column becomes null. If it is a not null constraint applied, then for example, if that column has a not null constraint, will it accept the null value? No. Are you getting my point? Everybody in online, are you getting my point? Have you understood what I'm saying now? Have you understood about what I'm saying now? Give me a reply. Question. Okay. Question. What's the question here? Can we map a Java class? Nothing but entity class. Can we map a Java class with a table having more columns? That's a question. Guys in online, you're not replying. Have you understood or not? Give me a reply fastly. Okay. Nice, good. So can we map a Java class with a table having more columns means what is your answer? Yes. Yes. But there is a rule. What is the rule? If the remaining columns does not have not null constraint. Who is the remaining column here? MGR. If MGR has a not null constraint, can we map it now? No. No. Because at the time of inserting an employee, MGR value is null. If it does not accept null value in MGR column, I will get an exception. So when can I map it? Provided. Okay. Yes. But if the remaining columns, okay, but if the remaining columns of the table does not contain what? Guys, does not contain what? Not null constraint. Not null constraint. Then we can do that. Otherwise, no. That is what you have to understand. Okay. Yeah, guys. Now coming to the next concept to learn is, see, we are not writing any Hibernate configuration file. We are not writing any Hibernate configuration file because now we are going to work with the JPA, right? I'll show you. Instead of writing Hibernate configuration file, we have to create a file called persistence.xml. What's the file name? Persistence.xml. Okay, if you are working with JPA and Hibernate, JPA as a provider or JPA as a specification and Hibernate as a provider, while working with Hibernate with JPA or JPA with Hibernate, whatever, we don't create hibernate.cfg.xml, but we create another file called what? Persistence.xml. One file we'll create. What's the file name? Persistence.xml. I'll show you how it looks like. There is a file you have to create called persistence.xml. Do remember, persistence.xml file must be under one folder called meta-inf. What the folder name? Meta-inf. Meta-inf in uppercase letters. In web applications, web-inf. Okay, web information. Similarly, meta information. That's called meta-inf. One folder is meta-inf. This folder you have to create at src/main/resources in Maven project. So what file we create in Hibernate with JPA? Persistence.xml file. Where do you keep this file? You have to store under a folder called meta-inf. That meta-inf folder is created in Maven project at src/main/resources. Observe here. Point what I'm trying to write is, okay, while working with JPA and Hibernate. Okay, while working with JPA and Hibernate. Okay, we have to create persistence.xml. Persistence.xml file under meta-inf directory. Next point. This meta-inf directory, remember this, guys. This meta-inf directory must be created under src/main/resources folder. Okay. What is the file you have to create now? Persistence.xml file you have to create. Where should I create this file, guys? Under meta-inf folder. I will show you how that file looks like. I will show you how the file looks like. Observe it. Guys in online, are you getting my point? Okay. Type C and whatever. Make it fast. Very good. Okay. Nice. I would like to tell you. You got my point now? Yes, guys. See how this file looks like. I will show you. Looks like Hibernate configuration file, but not Hibernate configuration file. Little bit different it is. I'll show you. Just wait for a minute. I'll show you how the file looks like. I'll show you. Look at this now. So this is the persistence.xml is a file. Okay. I will. Just a minute. You can able to see this clearly. Okay. So there is a file called persistence.xml. This file looks like this now. The root tag is called persistence. What's the root tag here? Persistence is a root tag. Like Hibernate configuration file contains root tag as what? Hibernate -configuration. One root tag is there, na? What is the file here? Persistence is a root tag. It contains persistence unit. We'll discuss about this next. And we should give some unique name for it. We can give any name here. Test, test one, example, sample, whatever you want. This is completely called one persistence unit. Whatever I have selected. Basically, persistence tag contains persistence unit. And it contains provider. You can see here. Who is my persistence provider? Hibernate. If you want to work with some other provider, then change this. Change this. Okay. So tell me now, I have to change my code or this XML? XML. My code remains constant. My DAO classes, my DAO interfaces, all the logic in my DAO, everything remains the same. Just what I need to do? Go to this XML, change the provider. Tell me currently I am using, who is my JPA provider? Hibernate. Tomorrow I want to use XYZ provider, then change here. Only this file you have to change. Don't touch remaining code. That is advantage. This is called loose coupling. This is called loose coupling. Now your application, you can change from the Hibernate to next to another tool also easily. How can you do it easily? By writing some changes to the provider, the XML file. That's all. This is the advantage. This is called what coupling? Loose coupling. Loose coupling between your application and ORM tool. ORM tool. Right? Of course. This is my entity class. If you have two entity classes, write all of them. Entity class means just now we discussed now. Right. Suppose my class name is employee or employee entity, whatever the class name. That you write. Fully qualified name. Then properties. What are the properties here? Java X dot persistence dot JDBC driver URL username and password. And these are common. Okay, these are for connection. To establish a connection, 4 values required. What are the 4 values required to establish a connection? Driver class, URL, username, and password. So those values you have to configure here. And apart from that, remaining properties. What are the remaining properties? Dialect, show SQL, DDL auto, format SQL. You know this? Already you know, I'm not explaining this because already we created in the last example one file called what, hibernate.cfg.xml. This also looking like the same, na? Correct or not? But with some small changes are there. But what's the file name here? Persistence.xml. What is the file name there? Hibernate.cfg.xml. This file and that file almost looking same, right? With a small changes. With a very small changes. Where should I keep this file? Under meta inf. What's the folder name? Meta-inf, cap letters. Where should I create a meta inf folder? Under src/main/resources. In the Maven project, 3 locations important. What are the 3 locations? src, main, Java. src, main, resources. src, test Java. In Maven projects, these are created. Here you can keep your source code. Here you can keep your test code, test cases. Here you can keep your other files. Tell me here, what's the next folder I have to create? What's the next folder I have to create? Meta-inf. Meta-inf. So I will explain you. For example, this is src/main/resources. Tell me under this, what I am creating under this? One folder I am creating. Suppose my folder name is meta-inf. Observe it. Capital letters only. Meta-inf. Tell me under this meta-inf, guys, what I have to do here? I have to create one file, guys. What's the file name? Persistence.xml. One file I am creating here, persistence.xml. File name must be lowercase only. This is XML. So you are not finding Hibernate mapping file. You are not finding Hibernate configuration file. In place of Hibernate configuration file, what file you are finding? Persistence.xml. In place of Hibernate mapping file, what are you writing? Annotations. That's all. You are getting my point now? Now this is how we are working with Hibernate and JPA. What is the advantage of JPA with Hibernate? We no need to make any changes in our DAO. What can I do? I can change the provider in the XML file to move from one ORM tool to earlier. What happened if I don't use JPA? I have to modify my complete code also. To modify, because in Hibernate we have session factory, session, transaction objects are there. But in next tool, you don't have session factory there. You don't have session there. Or you don't have any transaction class there. Am I right or not? There may be some other class are available. You have to modify the total code now. That is called what coupling? Tight coupling. But this is called what coupling? Loose coupling. You are getting my point? Right. That's what. Okay. You have to do this kind of examples. That's what we are going to start from tomorrow. Okay, guys. Yeah, guys. Everyone, have you understood the session for today? Give me a reply fastly. Whatever we have discussed in the session today, you got it or not? Everybody, please respond fastly. Write in chat box just one letter, C or N. Second switch. No. Oh, yeah, correct. That's. Yeah. Okay, guys. Okay. Nice case. Nice. Good replies. Thank you. Thank you. Okay, guys. Thank you, everyone. We will. Okay, we will continue tomorrow with the applications point of view. Okay, today we have discussed about how to write annotations and so and so blah blah blah. But we will continue with the applications tomorrow. From tomorrow, we'll begin with writing applications. Okay, guys. Right. I will share this whatever we discussed today. The document I'll share, and you just go through that. At afternoon timing, I'll share. Not now immediately. At afternoon, I'll share. Thank you. Thank you, guys. Thank you. We'll meet on tomorrow. Bye. Have a nice day.